So we have basically our final exam, open-ended questions. You're going to get these questions, all right, or extremely similar to, just different numbers. So you have your four kinematic equations, and one of these equations is going to be used in this problem. So first thing that we need to do in pretty much most of our problems is figure out our given pieces of information. A fighter jet is catapulted off an aircraft carrier from rest. That is your initial velocity. VI is 0. Up to 80 meters per second. That's your final speed. VF, your final velocity. All right, the runway that this is going off of, all right, the deck is 100 meters long. That is D. And they want to know what is the acceleration. So they want A. So first step, write out all your givens. Second step, look to see which equation has all four of these variables. All right, so let's see. All right, first one, do we have time? Do you guys see time? No. So we can't use that one. Does this one have time in it? Right here? So you can't use that one. And does this one have time? So you can't use that one. Okay, so we're looking at this one. Do we have VF? Yes. Do we have VI? Yes. Do we have A? Well, yeah, it's one of the variables we're looking for. And D. Yep. So this is going to be the equation that we need to use. All right, and how we go about this is, how I want you guys to do it is you're going to write the equation. Equals VI squared plus 2 times AD. Now, after you write the equation, you're going to plop in your information underneath. 80 is VF, so we're going to have 80 squared equals 0 squared plus 2 times A, which we don't know, times D, which is 100. Now we're going to start to simplify. 80 squared is 6,400. 0 squared, well, is 0, so that just doesn't happen. All right, see ya. Now, this one, 2a, is essentially like saying, oh, we have 3x. 3x times 100, which would basically be the same thing as saying 300. So since we have 2a times 100, this would equal 200a. And then we want a by itself, so we would divide both sides by 200. And that is going to leave us with a is equal to 32 meters per second squared.
How did you get 200?
Yep. So I took this 2 times whatever the distance here was, because it's a times both of them. Yep. Okay, this one. We got a lot of information in here, but I simplified it for you, okay? At point A, this is what your initial height is and your initial speed. At point B, this is now what your height is. We want to know what the final velocity is. So I basically simplified this as much as I possibly could for you guys. Since we're looking at the same mass, this 1.5 kilogram pork roll, egg, and cheese, all right? Yep, big sandwich. The mass of that isn't changing. So in this problem, we get to cancel out the m's because that won't change, and it just saves us a lot of writing. Your next step is to put in your variables underneath each one of these problems. All right, so VI is 12.5, so you're going to write 1/2 12.5 squared plus, we canceled out the m, so we're going to use g. All right, we've been using what number for G? 10. All right, we don't need the negative here. And the height, 36. That's our initial height, HI. We're going to bring down the equal sign. We have 1/2. We don't know what VF is. That's what we're looking for. So we have 1/2 VF. And don't forget, see right here in the equation, what is above VF? A squared. All right, so one of the students in my first period, they were doing this. They forgot that, and then they were like, "Why? The number seems really weird." And that was why. All right, so don't forget that. Okay, next thing, bring down the plus sign times. All right, so we now have G times HF. So 10 times what's our final height? HF, right over here, 9.5. Okay, so now we can move this because we have all of our numbers. We have all of our information embedded here. And now, guys, it just comes down to simplifying and doing the math. So in your calculator, you would do 12.5 squared equals, and then divide that by 2. Okay, that comes out to be 78.125. Bring down your plus sign. 10 times 36 is 360. Bring down the equal sign. We still don't know what this is, this piece, so we have to bring that down because we don't have any of that yet. So 1/2 VF squared. Bring down our plus sign, and 10 times 9.5 is 95. All right. So what I'm going to do here is I'm going to take these two. I'm going to add them together because I want to try and simplify everything down as much as possible. So when I add these two together, all right, my calculator gave me an answer here of 438.125, which would then equal this whole side over here. Here, 1/2 VF squared plus 95. So I'm going to ask you guys real quick. I want the 1/2 VF squared by itself. What do I do with this 95? Good. We need to subtract that from both sides. So now this becomes, when I type it into the calculator, this is going to wind up becoming 343.125 equals 1/2 VF squared. Okay. Again, we're looking for VF. So I don't like this 1/2 here. How do I get rid of the 1/2? Does anyone know? Good. You got to times it by 2. You got to multiply it by the inverse. Right? So if we had 3 over here, we'd have to divide by 3. For this, we're going to flip it. We're going to have to multiply this by 2 in order to get rid of that. So we're going to multiply this by 2. And that means we have to do it to this side. So we're left with 686.25 equals VF squared. Beautiful. Almost there. Guys, how do you get rid of a square? Very good. You have to square root. So you're going to square root this number, and that will equal VF. All right, so we type it into our calculator, and that value comes out to be VF equals 26.196 or whatever, so we can round that up to 26.2, and the unit for velocity, meters per second. All right, So again, you guys will have this question, but these numbers will be different. Okay, it's going to be the same problem, just different numbers. So you know how you have to do it. Okay, write everybody in, do the math, leave that, do the math. Get these guys, add them together, equals this whole side. Then subtract this guy from this side, boom, multiply them both by 2 to get rid of the 1/2, and then square root it. Okay, so for this one, I want you guys to fill in each of the missing pieces and show all the work. Now, I wrote these in a specific order for that reason. So your equation for Fg, force of gravity, or weight of an object, mass times gravity. The mass of this thing is 40 kilograms. So we're going 40. All right, we're using 10 for gravity, not 9.8. We're just doing the 10, which makes the calculations a little easier. And this equals 400 newtons. So now we get to write that here. Okay, so that's one of the things that you needed to find. Right? Boom. You see how you have these two equal signs? Right here. Equal, equal. Basically, that's saying, all right, this object's sitting on a flat surface. The weight has to equal the normal force. So no math is needed. All right, I'll just write this here. Fg is going to be equal here to Fn. So that for this is also 400. Okay. Now the next thing I asked you guys for is F net. The equation for net force is an object's mass times acceleration. You are given the mass and acceleration here, so we're going to do 40 kilograms times 4 meters per second squared. This gives us 160 newtons, but what direction is this going to be? Good. The net force is in the same direction as the acceleration. Now that's important. Really quickly, if I know that this is the net force, if I just drew a small little free body diagram, which is, remember, is a box, with just the net force on it, how would I draw that? Just with what?
Lines.
An arrow.
Yeah.
To show, all right, and it would be 160 newtons going to the right. So that means that this number, all right, or this force over here, the applied force, F applied, has to be 160 newtons greater than this. So there's not an equation you need here. You're going to just do friction force will equal your F net minus your applied force. So we're going to have 200 minus 160. I'm sorry, it should be applied force minus the net force here. So 200 minus 160, and that is going to give us 40 newtons. Now, since our F of F, or friction force, is over here, this 40 newtons goes right there. So you have now solved for Fg, and you showed the work. F net, we solved for it, showed the work. Okay, you just need to add the normal force in, but those are the equal. So once you have Fg, Fn is the same. And then to find the friction force, once you know what the net force is, you basically figure it out. Okay, well, if I need this to be the final answer, what would friction force need to be? So applied force has to be 160 newtons greater than that. So we take 200 minus 160, we got our 40, and therefore we have our friction force. So again, you guys will see this problem, just different numbers. All right, let's roll through. This is an inelastic collision. How do I know? Well, they're stuck together after the collision. So when you read a problem like that, all right, a grocery shopper tosses a 9-kilogram bag of rice into a 18-kilogram shopping cart or a grocery cart. The bag hits the cart with a horizontal speed. All right, now that says stationary, so that's why it's 0 meters per second. The bag has a horizontal speed or velocity of this 5.5 meters per second. Okay, what is the final velocity of the cart and the bag now that they're kind of stuck together? Once you guys have that, if you had to make a drawing, but you're going to be given the drawing, write the formula underneath it, and now it becomes super, super easy. 9 kilograms is this. V1 is this. M2 is this. V2 is 0. So plug in your numbers. 9 times 5.5. Bring down your plus sign. 18 times 0 equals M1 plus M2. So you do 9 plus 18 times, we don't know what VF is, that's what we're looking for. And now we do the math. So 9 times 5.5, this comes out to be, it's 49.5. Anything times 0 is 0, so this goes goodbye. So on the left side, we're left with just that 49.5 equals 9 plus 18 is 27 VF. And very simple, guys. If you want VF by itself, what do I need to do? Tell me. Good. Divide both sides by 27. And VF will be equal to a 1.83 repeating. We can leave it like this, or 1.83, and give me the unit meters per second. Dang it. That was such a... You see that? Look at how bad that rectangle is. Oh, that bothers me. Oh, that's annoying. Oh, well. Screw it. Moving on. All right. Let's take a look at this one. So in this case, if you had to make a drawing, you have a 4-kilogram raft moving to the right. Okay, so 4 kilograms, we draw the vector in. Cool. It makes a head-on collision with a 16-kilogram canoe moving to the left at 12 meters per second. So you would draw in a left arrow at 12 meters per second. After the collision, the raft, that was at 4 kilograms, is now moving to the left at 22.7 meters per second. So we would draw that. What is the new velocity of the canoe? So this 16 is the canoe. We don't know what the new speed is. So, same thing, guys. M1, V1, M2. This is our V2, our M1. Now this is V1 prime, that little apostrophe. It just means now that's the new speed of the other object after the collision. M2, we don't know that one. All right, so now plug in all your numbers right underneath everybody. So that's why it's very nice to write the equation out under the diagram, because now it just pretty much we drop things down. So 4 times 6 plus 16 times negative 12. Okay, you got to make sure you put that negative there. Equals M1 is 4 times negative 22.7. Bring down your plus sign. Mass here of 16 times V2 prime. And now, guys, it's just kind of plugging and chugging. 4 times 6, anybody? 24. Can you do something for me? No?
Why do you always do that?
Because the song, it I don't know, it's popular right now and it's just kind of stuck in my head.
Really? It's popular? I didn't, yeah.
It's not gone. It's not gone.
It's
I still hear it all the time, so zip it.
I think it's like,
Let me live my life. Anyway, moving on. 16 times negative 12. Negative 192. Bring down the equal sign. 4 times negative 22.7. Zip it. Negative 90.8.
I'm saying.
No. Bring down your plus sign. We don't know what V2 is yet, so you still have to leave this. Treat this as like one thing until the end. All right, so we're not changing anything here. Someone, all right, in my one class added negative 90 plus 16, but you can't do that because it's attached to V2. All right, so we got to make sure we don't do anything with this guy until the very end. So if we have a little bubble around it for now. Add these two together. All right, my calculator says it comes out to be negative 168 equals this side. We didn't change anything yet. Again, we want this 16 V2 by itself. Guys, how do I get rid of a negative number? You're going to have to add. So I am going to add a positive 90.8 here to get rid of that. But that means I have to add it to this side of the equation.
I'm so stupid.
No, not at all. Okay? No, you're not. Stop talking like that. Okay, when you do this, this gives us a negative 77.8. Nope, 77.2. My apologies. Equals, all right, now that that's gone, we're left with our 16 V2 prime. Now, how do I get V2 by itself? Now is where we do the divide. Okay, so we don't touch that. We don't touch that 16, all right, until the very end. And therefore, V2 prime comes out to be a negative 4.825 meters per second. All right, let's see if I can make a better rectangle here. Better. Definitely a little better. Not even a little better. Way better. Okay, so again, guys, you will have 4 of these. All right, different numbers. So you have these now. Okay, you have today to look at these. All of tomorrow to look at these. Friday, we're doing this. All right, you cannot use it during. All the equations will be given to you that you need. But you have to know how to do the math and the processes, okay? All right. Very good. Hold on. Very good. Signing off.